Okay, I am Dr. Shaviru Babu. So I am working as an assistant professor of physics in the Department of Science and Humanities. I did my PhD from NIT Warangal in the year 2014. Then I did my postdoc from Portugal in the year 2000, from 2015 to 16, and then recently I have awarded European Molecular Biology Organization a short-term fellowship to work on a reputed project which has practical applications in the field of medicine. Okay, so now as a part of our engineering physics course, in this lecture you are going to learn about mechanical properties of solids. The objective of this lecture is, so by the end of this chapter you should be able to understand what are the mechanical properties of various materials such as metals, ceramics, polymers and so on, and how we can use these materials in a prescribed in a particular applications. So that is the objective of this mechanical properties of solids. So now I would like to present you the syllabus structure. So the syllabus contains the introduction. In introduction we are going to see what are the important mechanical properties of solids, and then what is the need to study the mechanical properties of solids and so on. Then we are going to see stress strain curve, and then what is elasticity, what is Poisson's ratio, then creep, fatigue and failure, and what are the factors that influence the mechanical properties. Now we shall see in detail about the mechanical properties. We have various types of properties such as optical properties, electrical properties, thermal properties, magnetic properties and mechanical properties. So mechanical properties, among the mechanical properties, these four are the important mechanical properties. They are stiffness, strength, hardness and ductility. So these are the four important mechanical properties of solids. Now we are going to see in detail about these properties. That means what is stiffness, what is strength of a solid or material, what is hardness of a material, and then what is the ductility of a material. So before we are going to study about the mechanical properties of solids, we should have a minimum knowledge about what are these four properties. Now let us see one by one. Now first of all we shall see stiffness of a material. So what is the stiffness of a material? It is nothing but the resistance to the plastic deformation. So if you see here, resistance of an elastic body to deflection or deformation. That means the opposing force to bend itself or the opposing force to changes in its dimensions or the opposing force to strain. So now let us see what is stiffness. Suppose if I take a particular body of original of length L, and if I put that body on the two supporting these pillars, and if I apply some force, what happens is, some force means how do you apply some force? So if I put a particular, suppose this is a solid piece. Now let us suppose this is a wooden scale. If I put a mass, a body of mass m on the wooden scale, what happens is a gravitational force of mg will be acting towards the downward position. So a force which is equal to weight of the body will be acting on this particular wooden scale. Suppose if the mass of the body is very small, then there won't be bending of this wooden scale. Suppose if I increase the mass to 2m, then what happens? Let us suppose even for 2m also there is no bending. Suppose if I keep on increasing the mass of the body which is placed on the wooden scale, what happens is at a particular mass of xm, let us suppose at a particular mass, what happens is this wooden scale starts bending like this. So the mass at which, or the force at which the body suffers a deflection or undergoes changes in its dimensions is called stiffness of the body. So until the force or load less than this xm, it will not undergo any deflection or any deformation. That means, so that load or that force is called, can be considered as stiffness of the body. If the material is more stiff, then it will bear more load. That means we need to apply more force to bend a particular material. Suppose if I take for example, if I take wooden scale and an iron scale also, or steel scale. So which one is more stiff? Obviously iron scale is more stiffer than wooden scale, because if I want to introduce a deformation or deflection of iron scale, obviously I need to apply more load or more force on the iron scale compared to the wooden scale. So iron scale is stiffer than a wooden scale. So the stiffness of the body is nothing but the resistance of the body or a solid or a material for the deflection or deformation. So that is called stiffness of the body, which is very important parameter of the solids or materials, and we are going to see its significance in the coming discussions. So this is all about the stiffness of the body. Now the units for stiffness of a solid or a material is Newton per meter square or megapascal. The force which is generally applied per area. So Pascal is nothing but the unit for the pressure. Pressure is nothing but force per unit area. So Newton per meter square, or generally the stiffness can be measured in the units of megapascal. So 1 mega means 10 power 6 pascals, okay, or 10 power 6 Newton meter square. Since force is equal, pressure is equal to force by area. Force by area. So this is the unit for stiffness of a solid or a material. Now let us see what is the strength of a material. Now as we see in the previous case, suppose if we apply some load on a wooden scale at a particular load or at a particular value of force, it starts bending. Suppose if I apply more force, then what happens if I keep on increasing the force or load on the body on this wooden scale? What happens is at a particular load, this wooden scale will breaks into two pieces. So it breaks into two pieces like this. The ability of a material to withstand an applied force or load without a failure is called strength of a material. Other words, we can say the ability of a material to withstand to withstand an applied load before its failure or before its fracture. That means it breaks into two pieces. The amount of load at which the material breaks into two pieces is equal to its strength. So the units of strength also megapascal, because stiffness is also nothing but the load at which or the resistance of a body to the deformation. So that is also nothing but the load. Here also what we see is we apply load until the material breaks into two pieces. That means the force or load which requires to break the material into two pieces is nothing but strength of that particular material. So it is also measured in megapascal. You can see in this diagram. So we have a wooden bar, and a force can be applied by using the machine. The amount of force that has been applied by this machine can be read from the machine electronic circuitry. So as what happens is, as the force increases, so there won't be any deformation until a particular force, but at a particular force this wooden bar starts bending. That means that force or load at which this wooden bar starts bending is equal to its stiffness. If we keep on increasing the force, what happens is, at a particular force or load, this wooden bar breaks into two pieces. So that will be that load will be equal to its strength. So in brief, what is stiffness and what is strength? The stiffness is nothing but resistance of a body or material to the deflection or deformation. That means the load or force at which the body starts bending is called or is equal to the stiffness of that material. Suppose if you keep on increasing the load or force, what happens is that particular body breaks into two pieces, and the load at which it breaks into two pieces is equal to the strength of that particular body. So this is about stiffness and strength. And the third property of the solids or materials is hardness. So hardness is a property of a solid. It can be defined as the resistance of a body to the indentation or abrasion. So the resistance of a body by mechanical indentation or abrasion. So indentation means, so if you apply a load at a particular point on the body, what happens is the whole body will not exhibit deformation, but there is a deformation only at a particular place. That means the deformation of a body is localized. So what is happening if I apply force here like this? So there is a small bending of the surface of this particular body at this point, and that is called indentation. Another one is abrasion. Suppose if you see this diagram, we have two rolls, and these two rolls are allowed to move in a circle. While these two rolls are moving on the circle, what happens is there will be a friction between this plate and these rolls. So because of this friction, there is a process called abrasion. That means there is some scratches which we cannot see with our naked eye. Suppose if you see the scanning optical microscopy picture of this particular base plate, so it will be like this. So this kind of scratches are made because of the rolling of these rolls on this particular plate. So this is called abrasion and this is called indentation. So hardness of a material is nothing but the resistance of a body to plastic deformation or localized deformation, either by mechanical indentation or by abrasion. So indentation is there is a plastic local deformation, that means there is a bending of the surface at a particular point where the load is applied. So abrasion means, so because of the friction between the two surfaces or two bodies, we have a scratches on the bodies. So that is called abrasion. So hardness of the material can be defined as, so the resistance of a body to localized deformation either by mechanical indentation or abrasion. So you can see definition here. So this is nothing but resistance to localized plastic deformation induced by mechanical indentation or abrasion. This is about the hardness of the material. Now, for example, if I take a wooden piece and an iron piece, and if I take a nail, sharp nail, if I take a sharp nail and if I try to scratch, if I make a scratch on the, let us suppose this is wood, this is iron. If I try to make a scratch on wood by using this sharp nail, and if I make a scratch on the iron also with this sharp nail, what happens is we have a clear scratch on the wood, but it is very difficult to make a scratch on the iron or steel, because iron is having more hardness compared to the wood. So the abrasion or indentation is difficult, it is difficult to abrasion or indentation of iron, whereas you can easily make a scratch on the wood. So if the hardness is high, then we cannot make scratches. We cannot make scratches on a hard material so easily. Metals, if you take metals, most of the metals are harder materials. Okay, so most of the metals have high hardness. So this is about the hardness property of solids. The ability of a material to withstand load before its failure. Third one is, what we have seen is hardness. So it is nothing but the resistance of a body to the local deformation, either by mechanical indentation or abrasion. So we have in detail, I have explained you what is indentation and what is abrasion. And the fourth one is this ductility. So So ductility is very important property of metals. So because of its ductile property of metals, they have lot of applications in various types of fields. So this is all about important mechanical properties of solids. Now we are going to see the immediate question that arises is, why should we study these mechanical properties? So why do we study mechanical properties of solids? Suppose we have a policy. The policy is this one: cheap and best. The man is always looking for a better thing at a lower cost, so that it will be available to all the humankind at an affordable cost. Suppose if I want to make a cycle or a bike, and if I want to choose a metal or a material for a wheel, then I must have a knowledge about its mechanical properties such as stiffness and strength, mainly strength. Without knowing the strength of this particular wheel, I cannot use in a particular application. Suppose the same wheel which I use for cycle, I cannot use it for motorbike. The same wheel which I can use for motorbike, I cannot use it for car. The wheel which I can use for car cannot be used for bus or lorry, because the load is changing from vehicle to vehicle. So as the load is changing from vehicle to vehicle, what we need is, so there should be a higher strength material, and that the strength should be high, at the same time the cost should be low. So what people are doing is, they are searching for high strength materials which are available, which can be produced at a lower cost. So to find a material which is having very high strength and low cost, we need to study the different materials which are available in the nature. So by the study of the mechanical properties of available materials, then we can choose what is the best. Even though a particular material, having a material higher strength will not serve the purpose. So there is a condition, that is the cost. Cost should be low, that means it should be economical. Say for example, silver, if you take silver is having higher electrical conductivity compared to the copper, but we are using in almost all our applications copper instead of silver, because silver being a very high cost material, so we use copper which is having slightly lower, electrical conductivity compared to silver. So two things, one is the property should be high, strength of the material should be high, at the same time it should be available at a lower cost. So these two things influence. So to find the material which is having high strength or high mechanical properties, and at the same time the material which is having low cost, to find such a material we need to study the various types of materials that are available to us. Okay. So now, for example, if you take Boeing Dreamliner, so this is advanced aircraft Boeing 787 Dreamliner. Okay, so it has been mainly largely it has been made up of carbon reinforced materials, polymers, composites. Okay, so if you see the composites here, so this aircraft has been made by 50% of composites, 10% of steel, 15% of titanium, and 20% of aluminum, and 5% other materials. So by the way, in fact, the first plane is made up of wood, and then the whole aircraft is made up of aluminum, and then titanium comes into play. So titanium offers high strength and it is lightweight. The main requirement in aircrafts is the material should have high mechanical properties and other properties. At the same time, its weight should be very, very low, because what happens is, if the weight of the aircraft is increasing, then the fuel consumption increases. So they are both proportional to each other. Suppose if the weight increases, then fuel consumption is also increases. So to conserve the fuel and to save the money, or to make it to make the aeroplane traveling available to everybody, so we should decrease the cost of the maintenance. So what people are doing is, they are trying to make, they have made, say for example this aircraft, it has been made 50% by using carbon reinforced polymer composites. Okay, so if the weight decreases, fuel consumption decreases, and hence cost of maintenance will decreases. In fact, 12 liters of fuel will be consumed per 1 kilometer by the aircrafts. So for a car, so the 1 liter petrol gives around 20 kilometers mileage, but here it is reverse, 12 liters per 1 kilometer in the aircrafts. So suppose if, because of using these lightweight materials, it is goes down to approximately 8 liters per 1 kilometer in this 787 Dreamliner. Okay, so this is most efficient economic flight which is available today. Okay, and another thing is, in the engine, in the flight engine, very huge amount of heat will be produced, and the range of that heat will be 2100 degrees centigrade, and we need a material which withstands very high temperatures as well as low temperature, because this flight travels 12 kilometers above the surface of the earth, where the temperatures are minus 60 degrees centigrade. Minus 50 to 60 degrees centigrade temperatures will be maintained when it is in flight. So the engine materials, the material solids which we use for making the aeroplane engine, they should withstand higher temperatures as well as very low temperatures. So the selection of these materials is done by very careful investigation of all their mechanical properties, electrical properties, thermal properties, and so on. So we have to study in detail about the properties of the solids, especially mechanical properties of the solids, if you want to use them in a applications where in applications. Okay, so this is about the introduction of this chapter, mechanical properties of solid. Up to now we have seen introduction of solids. So up to now we have seen about the introduction. We have learned about what are the important mechanical properties. So among the important mechanical properties, we have seen what is stiffness, what is strength, what is hardness, and what is ductility. So stiffness is nothing but resistance of a body to the plastic deformation. Strength of a body is the maximum load that a material can withstand before its failure, and hardness is the resistance of a body to the plastic the localized deformation either by mechanical indentation or by abrasion. And then we have seen ductility. So that is the property exhibited by the metals. So that means these metals will exhibit a large plastic deformation. And then we have seen what is the need to for study the mechanical properties of solids. Now we are going to see the actual topic of these mechanical properties of solids. So let us start with engineering stress. So what is stress? The stress is nothing but, we can define stress as, if you see the formula, force by area. So we can define engineering stress as the force that is applied per unit area of the body. So it is represented by sigma. So this force is the applied load. F is nothing but applied load. A naught is the cross sectional area. So stress is nothing but, or engineering stress is nothing but the ratio of applied load to the cross sectional area of the body, or you can also define the amount of load that is applied for unit area of the body. So that is engineering stress. Say for example, if you take this particular block, this rectangular block, so the force is applied like this, okay. If you see, the area is small in this object, whereas the area is large in this object, but the amount of force that is applied is same. So the amount of force applied is same, but this body has smaller area, cross sectional area, compared to this body. So according to the formula, what happens is, so because A is small here, the stress is large for the same force. So remember, the force is same, the applied force on the two bodies is same, but the two bodies are having different cross sectional area. So if the area is high, then the stress will be small. So the engineering stress that depends upon the cross sectional area of the specimen or body. So if the area of the body is high, then stress will be small. If the area of the body is small, then the applied stress will be large. So if is force applied or load, So the units again here also what we are doing is we are applying a force. So that is nothing but load. So the units for stress also megapascal. Generally we take as megapascal or pounds per inch, that we don't use here. So the general unit that we use is megapascal. That means 10 power 6 Newton per meter square or psi, pounds per square inch. So this is about engineering stress. We have, the question is, where do we see this kind of stresses, or where do we apply this kind of forces or loads? We are talking about mechanical properties of solids. Suppose if I want to build a bridge on the canal by using the iron, then first thing I must know how much load will be applied on that particular bridge. That means whether the bridge is meant for walking of the persons, or is it meant for light vehicles, or it is meant for heavy vehicles, and so on. Okay. So if I make a bridge on a canal, then the vehicles will be going on the bridge. So the moment they enter on the bridge, they will apply some force. Suppose this is a bridge. So we have a, say for example, car like this moving on it. So what happens is, when it is on the bridge, it has mass mg. That force will be applied on that particular iron which is used to make the bridge. So this force will be applied, and if the body is having lower strength than the weight of the body, then the failure will occur. So these stresses will occur in many ways. If I stand on the floor, I am applying some stress because my weight is on the ground. Suppose if I press this body like this, I am applying stress. If a vehicle is moving, on the bridge, so some stress will be applied on the bridge, and so on. So we can have these kind of stresses many places. Now we have various types of stresses. That means stress can be applied, or load can be applied in various ways on bodies. So the first one is, this is called tensile stress. So we have a body. So this is the original body. This is the original body, and I am applying stress like this. That means force like this. So if I pull a particular thing like this, then what I am doing is I am applying tensile force. So this force is called tensile force or tensile stress. So if I apply like this, what happens is there is a change in the length. So if L0 is the original length, then length changes to L, where L0 is less than L. At the same time, when we applied tensile stress, so there is changes in the cross sectional areas. So this is the cross sectional area A0, and this is the cross sectional area A after applying the tensile stress. So obviously A is less than A0, or you can write A0 is greater than A. So this is one kind of stress, and this is the very familiar stress that has been applied in many bodies. And we have in mechanical engineering, we have a tensile test. That means the measurement of body strength by applying tensile stress. Okay, that is very famous experiment that every mechanical department has, that is called tensile test. So tensile stress is the first one. So when we apply tensile stress, so there will be change in the length as well as change in the cross sectional area. So the second one is compressive stress. The second one is the compressive stress. That means compressing. So applying the force like this. So when we apply compressive stress, what happens is L0 is the original length, L is the length after applying the stress, then L0 is greater than L. Similarly, A0 is less than, L0 is greater than L, so A0 is less than E. So here L0 is less than L, A0 is greater than E. So tensile stress and compressive stress, these are exactly opposite. In tensile stress we apply force like this, that means on both the sides the force will be directed away from the body, but in compressive stress from both the sides the force will be directed towards the body, on the body. Okay, so this is tensile stress and this is compressive stress. Third one is shear stress. So this is called shear stress. That means we apply force like this. So on the surfaces. Okay. So we have, this is the bottom surface and this is the top surface. So at the bottom the force will be in this direction and at the top the force will be in other direction. So because of this stress we have deformation, that means we have changes in the deformation will be induced and the deformation will be measured in terms of theta. And the fourth one is torsional strain. That means twisting. Suppose if I close the cap of a particular bottle very tightly, so what I am doing is I am applying torsional stress. So torsional stress. So what happens is, so we have a deformation like this. So it is supposed to be here, because we apply a force, torsional force like this, it is displaced from here to here. So these are the four types of stresses that we have that we encounter in our day-to-day lab or in our mechanical properties of solids. So the first one is tensile stress, second one is compressive stress, third one is shear stress, and the fourth one is torsional stress. So these are the four types of stresses that are available. Now we are going to see engineering a strain. What is strain? So if you see the definition here, so L0 is the original length of the body. So L is the length of the body after applying the stress, say for example tensile stress. So the strain epsilon is defined as, so L minus L naught is nothing but change in the length. L naught is original length. So the strain can be defined as the ratio between change in the length to the original length, or you can also define the change in the length divided by the original length is called the engineering strain or strain. So we can see here suppose if I take a piece of length L, or okay, we can go back. So if you see here, so L naught is the original length, and L is the length after applying the tensile stress. So because of this tensile stress, there is change in the length of the body. So the strain can be defined as L minus L naught divided by L naught. Sorry. Yeah. So L minus L naught by L naught. So the change in the length divided by original length gives us the strain of the body, or it gives the deformation, how extent the body is deformed because of the applied load or force can be given by engineering strain.